Example 2, give 3 other pairs of polar coordinates for the point P, which is 3, 140 degrees. All right, so I think the most obvious thing is to add 360 degrees. So one thing you can do is let's just add 360. Oops. So another way of representing this would be 3, 500 degrees. Okay? That's the same place. Add 360, add 360, add 360. I could do that an infinite number of times and get an infinite number of different representations for that same location. Okay? But that's too simple. Let's visualize where this is. 140 degrees puts us, I don't know, about there. So let's say that's a distance of 3 at an angle of 140 degrees. So this is the point 3, 140. Think about other ways of representing this point. Okay? One thing we could do is go around backwards. If I went around backwards, that's 180 plus some more. That's a 40-degree reference, by the way. What is that angle if I go around backwards? Negative 220. That's a negative 220-degree angle. And so another way of representing this point would be 3, negative 220 degrees. Okay. Let's see, what else could I do? I guess I could think about kind of the anti-point, I guess, right here. If you go, what would that be? 40-degree reference all the way around except for that 40, that's 320 degrees. If you went around 320 degrees, you'd be at this point. And so what I could do is say, go 3 in the opposite direction from 320 degrees. I kind of don't like that way, but that'll work. And of course, you can always just add 360, add 360, add 360. So you have 3 other pairs of polar coordinates. Got it. All right? Part B, determine 2 pairs of polar coordinates for the point with the rectangular coordinates -1, 1. We've been doing this for the last couple of lessons. You have to recognize that when they say they want polar, that means they want r and theta. And when they say we have rectangular, that means we have x and y. And so we're using those formulas to go back and forth. We're taking our x and our y and we're changing it into r and theta. We want polar, so we want direction and magnitude. So let's start with magnitude. We know the formula looks like this. We've used it for the last 3 lessons. So square root of -1 squared plus 1 squared, that's square root of 1 plus 1, or square root of 2. That's the magnitude, the r value. As for my direction, tangent theta equals y over x. Or in this case, tangent theta equals 1 over -1. You want to be able to use the chart and find what angle is going to give us a tangent value of 1 over 1. Okay? You guys see how that's going to be 45 degrees? That's going to be a 45. Now, that's not the answer. -45 is not the answer. We're talking about a 45-degree reference where tangent is negative. And so think about where that is. Tangent is negative in quadrant 2 and 4. However, we know where we are. The point is at -1, 1. -1, 1 puts us in which quadrant? Left 1, up 1 puts us in the second quadrant. And so what we're really looking at is a 45-degree reference in that second quadrant. What angle are we talking about? 135, very good. 180 minus 45 is 135. And so I've got my magnitude and I've got my direction. That should be enough for polar coordinates. Polar coordinates is going to be square root of 2, 135.